In this video, I'm going to go over the concept of transformations just a little bit in 1.5 electronic homework number 15. So you have a multiple choice question here. We have the graph of f of x equals 2 to the x, which is an exponential function. We'll be doing a lot more with those later. But for the basics, this is just one of your graphs that in the library of functions. So we will learn more properties about this, but for now you could just kind of look at the one they give is the black line. Okay, that's the function itself, 2 to the x, and then match each transformation of this function with the graph below. So if I look at, we could do it by looking at the graph first or the equation first. How about we look at the graph? So I'm going to look at the red one, and I can see that my curve here is reflected over the x-axis. So that means all my y values got changed around to be the opposite, right? So that would be the negative. So that would be, for the red one, I would have this right here, negative 2 to the x. Okay, so I'm going to say C there for that one. Now, if I want to look at the green, we'll just pick green now. And how does that relate to the black line? What's happening with it? That one's just a little bit trickier, right? So first of all, we can see that everything's now over the other side of the axis, but also something else has changed. So it might be helpful for us to just make a little table here for the parent function. So if we have y equals 2 to the x, I mean, look at the graph over here, we can see the points, but you can also just plug in values. You can say if x is -1, then y would be 2 to the -1, which is the same as a half. And then if x is 0, we'd have 1, because anything to the 0 is 1. If we had x equal to 1, we would have this point here. If I had x equals 2, then I'm going to be going up off the chart there to 4. So then if we look at the green one, we would just check that out. Let's just see what those values are going to end up being for the green. Okay, so if I look at the green, I have, instead of 0, 1, I have 0, -1. So I know my y changed to a negative. And instead of, let's look at when I have -1 for my x value. About here, my y value is -2. Okay, so that's changed. So not only did my y value change, so instead of +2, I have a -2, but my x also changed. So now that is negative. So I'm reflecting over the y-axis also. And then if I just get a couple more points, I can look here and see that when x is 1, y is going to be -1/2. So not only is my y changing sign, but my x is changing sign as well. So that means that I have this situation here. I have a reflect over the x-axis. That's making all my y values, or my f of x's, become negative or opposite. Not necessarily negative, it depends what they started as. So opposite what they started with. And this negative x up here affects the x, so that's going to reflect over the y-axis. So I have two different things going on. So the green goes with that first situation, -2 to the negative x. And then 2 to the negative x down here, well, that's got to be the blue. That's the only one left. But let's just make sure we check it out. And we can see on the blue that we have that same y value as on the parent function. So we have that 0, 1, the same y-intercept. But you can see if you put a mirror up, it would reflect over the y-axis. So that one is going to be my blue. Okay, so that's a little bit on the concept of how we do the reflections.